Good day, students. In this video, we're going to discuss how to compute probabilities using the standard normal table. But before we have our discussion, let's have a quick review of what is z-score. Again, a z-score is a measure of how many standard deviation a data point is away from the mean of a distribution. So it's either above the mean or below the mean. So if it's above the mean is 0 because it is standardized. Therefore, the z-score is positive. If it's below the mean, therefore the z-score is negative. What is the relation of z-score and probability? So the relationship between the z-score and probability is that z-scores are used to calculate probabilities for normal distribution. A z-score represents the number of standard deviation a particular value is from the mean of the distribution. Probabilities can be calculated using the standard normal distribution table. These probabilities correspond to the area under the normal distribution curve, and they represent the likelihood that a randomly selected value from the distribution will fall within certain range of values. So for example, if we want to know the probability of obtaining a value less than or equal to a particular value x from a normal distribution with a given mean and standard deviation, we can first calculate the z-score of x using the formula x minus mean over standard deviation. Then we can look up the probability associated with the z-score in a standard normal distribution table. Find the area under the curve to the left of the z-score. So actually, that is our topic for today: how to compute or how to know the probability based on the z-score that we have. So let's start. So the objectives is compute probabilities using the standard normal table. Before we compute for the probability using the standard normal table, you must first know how to do probability notations. What is probability notations? Here's an example of a probability notations. So P is for probability. P of A is less than Z is less than B. So it denotes that the probability that z-score is between A and B. So A and B are z-score values. So next, probability notation. P of Z is greater than A. So this denotes that the probability that the z-score is greater than A. Okay, so A again is a specific Z value. Then P of Z is less than A. This denotes the probability that the z-score is less than A. Again, A is a Z value. So let's have an example how to do probability notations. So for example, to denote the area between Z is equal to 1 and Z is equal to 2, we use the notation. But before I show the notation, let us solve for the area. So before we solve for the area or the probability, I suggest you illustrate first what is being discussed. So let's illustrate what is being asked. Okay, so this is a standard normal curve. Mean is 0. Standard deviation of 1. Z is equal to 1, so this is 1. And Z is equal to 2. The question states that what is the area between Z is equal to 1 and Z is equal to 2. So let's shade. So this is Z is equal to 1 and this is Z is equal to 2, and this is the area that is being asked. So more or less we have an idea of what is the area or the percentage that we are going to solve. So again, how do we solve this type of question? Pause the video and try to answer how to solve this area. Okay, in solving this area, we just get the value of P of Z is equal to 1, and that is okay. So according to the Z value table, Z is equal to 1 is 0.3413. How about probability Z is equal to 2? 2 is 4772. So what do we do with these two areas? Okay, so based on our illustration, we know that half of the normal curve is 50% or 0.5 in decimal. Okay, so if that is 0.5 and we have two areas, 0.3413 and 0.4772, what is the most logical way to identify the shaded part? Okay, so we will subtract. So what is the notation? What is the proper notation? The area between two z value. P of 1 is less than z is less than 2. So that is the probability or the area. We will subtract the larger area minus the smaller area. 0.1359. Okay, so that is the area between z is equal to 1 and z is equal to 2. Okay, so the notation is p of 1 is less than z is less than 2 is equal to 0.1359. Okay, so thus the probability that the z is equal to 1 and z is equal to 2 is 0.1359. So again, I suggest the first thing you will do is to illustrate so that you have the idea what will be the area that is being asked. Okay, so let's have another example. Example number 1, find the probability of the area above z is equal to -1. So again, I suggest you illustrate. So more or less, we have an idea what will be the area. So this is 0, and we are talking about -1. So -1. Find the probability of the area above. So above -1. So this is -1, and we will shade to the right above. So this is the area, and if you can see, this is more than 0.5. How do we compute for the probability of the area above z is equal to -1? So first, so the area of z is equal to -1. Okay, so it is the same as 1, right? So let's check. So 1 is 0.3413. So what is the proper notation? So the proper notation is p of z, so it is greater than, because above. Okay, so z is greater than -1. What do we do with 0.3413? Is that the final answer? I don't think that is the final answer because the shaded part is more than 0.5, right? So therefore, we must add 0.5. Area that is above z is equal to -1 is 0.8413. Okay. So thus, the probability is 0.8413 or 84.13%. So let's have number 2. Find the probability greater than z is equal to 1. So the area that corresponds to z is equal to -1 and the area that corresponds to z is equal to 1 is the same because they are with respect to 0. Let's illustrate. So this is 1, this is -1, this is 2. We are going to identify z is equal to 1, the probability greater than 1. So let us shade greater than or above. So this is to the right. The area that corresponds to z is equal to 1 is 0.3413. Then the proper notation is z is greater than 1. 3413. So what do we do with 0.3413? So based on our illustration, it is less than 0.5. Instead of adding 0.5, we will subtract 0.5. Okay, 0.5 minus 0.3413. So the area, so the probability greater than 0 is equal to 1 is 0.1587. Thus, the probability is 0.1587 or 15.87%. Number 3, find the probability to the left of z is equal to 1.5. So again, I suggest we illustrate so that we can have a visual representation of the problem. -1, this is -2. So -1.5 is between -1 and -2. So this is our border. And find the probability to the left. Okay, so if we can check, based on our illustration, it is less than 0.5. The z-value table is the area between 0 and the z-value. Okay, so it doesn't matter if it's negative or positive because they are symmetrical. So what happens in the positive also happens or will be the same to the negative. Okay, so what is 1.5? What is the area that corresponds to 1.5? 1.5 is 0.4332. So that is the area that corresponds to 1.5. Okay, so let's have the notation, the correct notation. So z is less than. So when you say to the left, it is less than negative 1.5. How do we solve for the correct area or the probability? Based on our illustration, it is less than 0.5. 0.5 minus 0.4332. The area is 0.0668. Okay, clear? So let's see the presentation. Okay, thus the probability is 0.0668 or 6.68%. Number 4, find the probability below z is equal to 1.5. Again, let us illustrate so that we have an idea of the question. So 1.5 is in the middle of 1 and 2. Then find the probability below. So we will shade to the left. Based on our illustration, it is more than 0.5, correct? Let's proceed to the notation. Because we know what is 1.5, it is the same as negative 1.5, 0.4332. So the notation will be z is, find the probability below, so below, so less than 1.5, positive 1.5. Okay, so we will add 0.5 to 0.4332. So plus 0.4332. So the total area is 0.9332. It is recommended to create first the illustration so that you can have, so that you will know what to do with the area. Will you add 0.5? Will you subtract 0.5? So that's the probability of z value below 1.5 is 0.9332 or 93.32%. Clear? So next, find the probability between z is equal to negative 2. So this questions tackles probability between two z values. First, we have z is equal to negative 2 and z is equal to 1.5. So let's illustrate. So find the probability between negative 2 and negative 1.5. So this is negative 2. This is negative 1.5. So is this a large area? So based on our illustration, based on our drawing, it is a very small area. So again, how do we solve the problem? Ask us the area between or the probability between two z values. The procedure is we will get the area that corresponds to each z value. So the area that corresponds to b p of z. Let's have first the area of z is equal to negative 2. The z value table, 2 is 4772 and 1.5, z is equal to negative 1.5 is 4332. So let's have the notation of the probability between z is equal to negative 2 and z is equal to negative 5. So p is negative 2 less than z less than negative 1.5. So we have two areas. What do we do with the two areas? Shall we add or shall we subtract? We will subtract because if we will check the illustration, it's very small. Therefore, we will subtract. Thus, the probability is 0.0440 or 4.40%. Number 6, find the probability between 0.98 and 2.58. So again, we will illustrate. 0.98 is almost 1, right? So this is 0.98. And 2.58 is between 2 and 3, so more or less here. So this is the area. So again, we will get the z. So P of z is equal to 0.98 and P of z is equal to 2.58. So what is the area that corresponds to 0.98, 0.3365? How about 2.50? Okay, so 2.58 is 4.4951. Okay, so what do we do with these two areas? Okay, so the rule of the thumb in getting the area that is between two areas, if they exist in the same side, it's positive, or the same side negative, so we will subtract because they exist in, so therefore the area will be subtracted, the two areas will be subtracted. While if the two z values have different signs, the one is negative and the other z value is positive, then the two area that corresponds to those z value will be added. Okay, so that is the pattern that we see in these problems that are the probability between. Okay, so the proper notation, so the correct notation is z 0.98 is less than z is less than 2.58. The larger area is 4951 minus 0.3365. Okay, so let's subtract. The probability between z is equal to 0.98 and z is equal to 2.58 is 0.1586. Thus, the probability is 0.1586 or 15.86%. Okay, next problem. So 2.37 is more or less here. So this is the area. So obviously, this is more than 0.5. 0.4911, 0.4911. So what do we do with these two areas? So again, if the z values have different signs, we will add. Okay, so the proper notation is negative 1.32 is less than z is less than 2.37. Okay, so the area between negative 1.32 and 2.37 is 0.8977. Okay, thus the probability is 0.8977 or 89.77%. Find the probability between 0.92 and z is equal to negative 1.75. Then 0.92 is almost 1. This is 1. So here. So this is the area that is between negative 1.75 is less than z is less than 0.92. Okay, 0.7811. Thus, the probability is 0.7811 or 78.11%. Word problems. So the weights of adults in Barangay X approaches a normal distribution with a mean of 52.9 kilograms and a standard deviation of 7.2 kilograms. If an adult is chosen at random from Barangay X, what is the probability that his weight is above 48.5 kilograms? In dealing with word problems, you need comprehension and analyzation. So aside from illustrating the given, translating it to standard normal curve, I suggest you list down the given. Before we get the probability or the area, we need the z value. So first, we will solve for z value. What is the formula for z value? Z value is x minus mu over standard deviation, or 48.5 minus 52.9 over 7.2. So if you will notice, 48.5 is below the average or but below the mean. Therefore, we expect a negative z value. Negative 0.61. So rounded off to two decimal places, it is negative 0.61. So let's have the notation. So P of z is greater than negative 0.61. We can illustrate the standard normal curve. So where is negative 0.61? So it's between negative 1 and 0. It tells us it is above. So we will shade to the right. We will shade the right side of negative 0.61. So based on our illustration, it is greater than zero point 0.5. The value 0.61 is 0.2291. So what do we do with 0.2291? So we will add zero point 0.5. So zero point 0.5 plus 0.2291. So therefore, the probability that his weight is above 48.5 kilograms is 7291 or 72.91%. Then you will give your conclusion. So the probability that his weight is above 48.5 kilograms is 72.91%. So that is your conclusion. Thus, the probability randomly selected adults weighs above 48.5 kilogram is 0.7291 or 72.91%. Okay, next problem. A brisk walk at 4 miles per hour burns an average of 30 calories per hour. If the standard deviation of the distribution is 8 calories, find the probability that a person who walks 1 hour at the rate of 4 miles per hour will burn the following calories. Assume the variable to be normally distributed. So don't be, in this type of questions, don't be intimidated because of the rate of change, calories per hour. That will serve as your units of measurements. Okay, and actually, to be specific, it is the units of rate of change. Letter A, more than 280 calories. So first, let's write the given. So a brisk walk at 4 miles per hour burns an average of 300. So we need the average. So mu is equal to 300. We need the standard deviation, 8. X is 280. So if we will check 280, let's standardize the given using z value. So z is equal to x minus mu over standard deviation. So x is 280 minus 300 over 8, negative 2.5. If we're going to illustrate this, negative 2.5, so that we can have an idea. So this is negative 2.5 to the right or more than, so we will shade to the right. The probability notation, z is greater than negative 2.5. So we have 0.5 because this is the shaded part is more than 0.5. So 0.5 plus what is negative 2.5 z value, or what is the area that corresponds to 2.5, 0.4938. So the total area will be, or 99.38%. So the probability of a person who walks 1 hour at a rate of 4 miles per hour that will burn 280 calories is 98.38%. Thus the probability is 99.9938 or 99.38%. Letter B. What is the probability that a person will burn less than 294 calories? Mu is 300. Standard deviation is 8. X is 294. So Z is equal to 294 minus 300 divided by 8. Negative 0.75. Okay, so if you're going to illustrate that, so negative 0.75 is approximately here to the left because less than, so we will shade to the left. P of z is less than negative 0.75. The shaded part is less than 0.5, so 0.5 minus is the area that corresponds to 0.75, 0.2734. So what is 0.5 minus 0.2734? So the probability is 0.2266. So therefore, the probability that a person who walks 1 hour the rate of 4 miles per hour that will burn less than 294 calories is 22.66%. Clear? So let's have letter C. What is the probability that the person will burn between 278 and 318 calories? So given, okay, so we have two x value. So x1 is 278 and x2 is 318. So we will solve their C value respectively. So Z1 is equal to 278. So one is below the average and one is above the average. So 278 minus 300 divided by 8, and one is Z2 is 318 minus 300 over 8, negative 2.75, 2.25. So this is a very large area, right? 2.25 is more or less here. Obviously, we will add the area that corresponds to the z value. So what is the z value? So let's have the notation. Okay. So what is 2.75? 2.75 is 0.4970. Okay, 2.25 is 0.4870. 0.4878. Okay, so very large area or very high probability. So the probability that a person who walks 4 miles per hour will burn between 278 and 318 calories is 98.48%. So that is a very high probability. That's all for today. If you have any questions, you can post it in our Google Forms evaluation. Have a great day. God bless. Bye-bye.